The last problem. Jude is standing on top of a 60-foot building. He drops a coin 4 foot above the height of the building. So the building is 60 foot. So let's just draw this. So we have a building and it is 60 feet high. And then you have Jude standing up here, 4 feet tall. So that's going to be a total of 64. And then he is going to drop a coin. And yes, it is going to have the shape of a parabola because time will go by. So let's draw this. This is my x-axis from the drop of the coin down the building is our y-axis. And then of course, this part of the parabola is going to be irrelevant. So we are going to start at 64. That's the y-intercept. It is also the vertex, right? You see that? So it's the vertex, tells us how high the object's going to be. It's starting out as high as it's going to ever be, 64 feet. And then as it drops, some time will go by. And that's what we're trying to find out. How long does it take to hit the ground? So let's write the function. We do not have a b value. We do not have a velocity. It's not being thrown. It's just being dropped. And then we're starting out at 64. Now, looky. Here, I know that 64 is divisible by 16. So I am going to factor out negative 16, and I'm left with t squared minus 4. I can factor this binomial. It is the difference of two squares. The difference of two squares, dots. So when I have a difference of two squares and my middle term is 0, it's going to be the square. I'm going to take the root of t squared. I'm going to take the root of 4, and 1 is plus and 1 is minus. So my quadratic has 3 factors. We know we are going to set those equal to 0. And we know several are irrelevant. This is false. This is going to give me negative seconds. And this is going to give me the seconds I'm looking for. So this is 2 seconds. This root is negative 2 seconds, which is irrelevant. So it takes 2 seconds for the coin to land.